So here they are saying define what is sampling. So the keyword here is that you are selecting a subset of individuals from a larger population. I will say process of selecting a subset of individuals from a larger population. So this one is the definition for sampling. Then the next one, they are saying define what is a census. Or census, and then it's a this one, the key members that were the keyword is that we are selecting from a single population. So it's a study that involves collecting data from every single member of a specific population. Then they say differentiate between descriptive and statistical inference. So descriptive statistics, this one, it focuses on summarizing and organizing that through numerical summaries. And then we have got a statistical inference. This is based on predictions. So say it uses data from a sample to make generalizations. Predictions and decisions. So but the most important term is predictions. And then let's come to give two reasons why we use sampling instead of conducting a census. Why we use sampling? Let us see. So why we choose sampling over census? So this is based on two points: cost effectiveness, and number two is time efficiency. So sampling allows much faster data location. It allows for much faster data collection. So in terms of the cost, when you are doing sampling, it's cheaper. It's cheaper to collect data from a smaller group than the entire population. So I'll just say pop. Then we'll come to the next one. They were saying define, let's see, examine the expression Q equal to X minus EX and explain whether Q is a statistics or a pivot. Assume the variances are known. So analyzing this. So must choose whether it's a statistic or a pivot. So we know that E x bar is going to be equal to mu. So, and we don't know the value of the mean, right? So this is not a statistics. So Q is not a statistics, because a statistics depend on the sample data, but the pivot, it does not depend. It does not depend on the data. So the distributions are usually independent when it comes to a pivot quantity. And then we know that the normal will follow, in general, on normal distribution, it will follow this. And we're having Q is equal to x bar minus mu. So we're having the normal. Then we can say that this one is what is 0. This should be over n. We can say that this is 0 mu squared, your variance squared over n. So Q, since the variance, if we check the variance here, is unknown. So Q depends on what? On an unknown parameter. Therefore, Q is not a pivot quantity. So we'll discuss this more. So let's now check the calculations on question 2. They're saying let Q equal to this and also let W equal to this. So we know that Q is the summation of Yi and W is Q over M. Now they are saying, what does the phrase a random sample of size M indicate about the relationship between the random variables? And this is 2.1. So we do notice that Y will be normally distributed between me and this generally, and then the MGF of Y will be E mu T plus half sigma squared T squared. So we're trying to show that we must show the relationship between the random variables. What does the phrase of the random variable of size M mean? So you're going to do this. You're going to find the MGF here. So you'll say MY. If I say MQ, because we're given this, we want to find the MGF. So this will be the product of this. Then this will be the same as E mu T plus half sigma squared T squared, then all to exponent M, Y to exponent M. Let's check. They said okay, because we're ending at what? At M. Next, we are starting from I equal to 1 up to M. Then this will be equal to E M mu T plus half M sigma squared T squared. So Q is normally distributed between mu and mu squared. So this is your mean, and then this is your variance in this case. So we see that this depends on the value. So we can say that the value of our observations does not affect the value of the others. So we can say y1, y2 up to ym are independent, since each y follows n mu, it still follows this, and we've got independence. So this is what they wanted here on this question, for us to just show this, but we'll discuss more of this. And then they say we want to derive derive the sample distribution using the MGF method of Q. Number B. So we know Q is equal to this, and Y is normally distributed between the mean and the variance, and we know the MGF of Y in terms of T would be equal to E mu T plus half sigma squared T squared. So we can now say MQ of T will be the MGF of Y from I equal to 1 to 0. Then this will be, so remember, this is how you're going to write your MGF. It's E mu T plus half sigma squared T squared all to exponent m, and this will be m mu T plus half m sigma squared T squared. So the reason here we're saying m, recall that if your MGF, let's just say MQT, so the variables of Y will be independent if and only if the product is equal to the MGF. So meaning MYIT, MY2T up to MYMT. Now this will be the same as M1 is equal to M2 is equal to MY3 and so on, and then this will be equal to MYM of T. Then if we change this due to that M, then you'll say E mu T plus this by property of MGF. So you must indicate by property of MGF. So even here I forgot to include that. You should write the reason by property of the MGF. So now you will be having this, and then we can clearly see that MQ of T is just equal to this. So it means this is normally distributed between these two values. So we can say we've got Q follows a normal distribution of M mu and M sigma variance squared, and then we're done. So we've managed to show this. Remember, the question wanted us to derive the sampling distribution of Q. So that's our sampling distribution of Q. We got Q normal distributed between M mu M sigma squared. And they say derive the probability distribution of Z squared using the CDF method, cumulative distributive of random variables of Z squared. So we know that generally Z will be equal to Y minus mu over sigma, and Z is normally distributed between 0 and 1. So if U is equal to suppose U is equal to this, so the CDF of U, which will be F of U, will be equal to the probability of Z squared less or equal to U. Then you'll get probability of negative. You'll first take this to the left, then you'll have something like this. Then you take the square root, you'll have negative root U. Then we can say I have a new function, then we just change this. So this, we know that it's equal to, when you are having something like this, we know that this will be equal to the function of B minus the function of A by property. So you'll have this. So it's equivalent to this. Then to find our CDF, we're going to differentiate. So to find FU, the PDF probability density, we're going to differentiate our function. And then this will be equal to 1 over 2. We know that this will be equal to 2 pi, 1 over root of 2 pi e negative x minus mu over z all over 2 in general, by the normal distribution function. So now it means this will imply that Fu will be equal to, then we differentiate this. Suppose that now we let this to be U, then over 2. So this means that since we are having that, remember that here we are having root of U. It means we are having the root, you see, the root of that. So basically this means that here I'll have multiply by U to exponent negative half. This, I think it should be times half here. When you differentiate the root of U to exponent half, this will be half U negative half, which is just half root of U. Yeah, then it means that Fu will finally be equal to 1 over 2 root of 2 pi e negative, and then we must replace our value of U is Z squared. Then you have Z squared negative half times half, or we already have the half, and this will be 1 over 2 root of 2 pi e negative Z squared over 2 Z negative 1. So basically, if we are leaving this in terms of U, we will have 1 over 2 root 2 pi U to exponent negative half, and then e negative U over 2, if we decide to leave everything in terms of U. Yeah, actually this is what they were looking for. Then we'll come to, okay, let me cut this recording here. But for this one, the next one was the distribution of this. You should get, this is a chi-squared distribution, so I will explain this. Then our degree of freedom here, I believe that it's going to be this 10. Then you'll have x squared 10.